Hello, my name's Professor Will Swan, and I'm here to talk to you about the Salford Energy House and Energy House research facilities that are based at the University of Salford. I'll be joined to talk about specifically Energy House 2 by Dr. Richard Fitton, who's part of the leadership team at Energy House Labs. So just to give you a very quick overview of what we do everything to do with energy in buildings, particularly in housing. But we're probably most famous for the Salford Energy House, which I'll explain in more detail, but very simply is a whole building within an environmentally controlled chamber. And this area of expertise is the area we're probably best known for. But we also have a thermal measurement laboratory, which covers the performance of insulation. It's a UCAS accredited lab. We also have the smart homes and smart meters lab. And that covers all things around smart energy and Internet of Things and data analytics, which is obviously an increasingly important area, which I'll show later. And finally, Energy House 2, which my colleague Richard will give you more detail on as it approaches its completion. So the Salford Energy House was a very original concept when it first came out. It was constructed in 2010 and 11. And became operational around 2012. And so the house itself, as you can see here, is a Victorian pre-1919 end of terrace Victorian property with a half house or a conditioning void on the other side, because obviously an end terrace does not exist in isolation. And the reason we built this was really to address the retrofit agenda. And one of the things that we noted was actually field trials were very difficult, and anyone who's done field trials will understand, issues of access, issues of sensors not working. So what we felt was if we could do something in controlled conditions, we would be able to quickly help product manufacturers innovate. And so the chamber itself was a concrete chamber that used to contain a Van de Graaff generator, became an environmental chamber, and then we built using reclaimed materials and traditional methods. So it's a suspended timber floor, lath and plaster ceiling, lime mortar. So all of the traditional ways of building Victorian properties. And we just brought it up to a sort of reasonable modern standard. So it still retained its original sash windows, but did have a modern heating system, a gas combi system. So what makes it different is that it is under controlled conditions. So we can drop the temperature down to -13, up to +30 and hold it within half a degree. We're able to put wind across certainly the gable end faces, and some of the reasons we moved to Energy House 2 will explain some of the limitations of the chamber. We've also put solar heat onto the surface of the building using solar lamps and DMX lighting system. And we can also put rain and snow onto the surface of the building. And then on the other side, what we have is a huge number of sensors. So everything is monitored in there. The system puts out around 5 gigabytes of data a week. So the environments, both inside and outside the building, are monitored. All of the systems are monitored. Energy consumption is monitored. And then also the building is controlled through a series of actuators to allow us to replicate how people inside the building may live. So they can turn things on and off, open doors and windows. And really, this gives us 3 big advantages. The first really is around repeatability. The ability to do repeatable experiments gives us a real clear idea of what an improvement is being made by a particular intervention. So this, with a new retrofit product, can go into the property, it can be tested before and after under exactly the same conditions. So that gives us a real understanding. We can never really completely replace field trials, but as a field trial is quite expensive, it just gives us an opportunity to understand what works and what doesn't. The second is one around data granularity. So we will have more than 300 sensors. We can add sensors, we can add different types of rigs, such as to measure operative comfort. And this gives us real data granularity, so we can get the kind of detail that we really cannot get in the field. And then the last thing is access. So we can go in, change things, rip things out, throw things away. So it just gives us a really clear idea of whether an individual intervention or group of intervention works. So I'm just going to give you a very quick example of a couple of types of projects that we do. So this is a project we did actually with Leeds Beckett and Sangabam. And it was in 2013-14, we did a whole house retrofit. Now we're currently in the middle of another whole house retrofit project with Leeds, Beckett and Loughborough. And it's very similar to this project, but obviously with different products. So we did a full retrofit of the building. But what we did that we were able to do that no one else had been able to do was to retest by taking one thing off at a time, so we could see the impact of individual interventions. So this was very unique at the time. There had been an attempt to do something like this in the field in a previous project, but obviously the weather proved the confounding factor. So this has allowed us to take, the gable end insulation off and take the roof insulation off and retest. So, and it allowed us to do multiple tests as well. So this gives real insight into the performance of the retrofit. So if we fast forward a few years, we see retrofit in a slightly different way. That previous project was all about fabric. So this is a project we did called Haven, which is really looking at the different types of energy system that are starting to emerge in retrofit. So we're looking at multiple assets under control, smart energy systems using smart meters. So what we had there was a vehicle to grid charging system, a Mixergy smart hot water tank, a Tesla battery, a NEBI heat pump, and photovoltaics, looking at the ways houses can generate, store and consume energy. So what we see is that things have moved on. So the retrofit is a combination of very much now fabric systems, because it's not just necessarily how you use or how much energy you use. So it's not just an energy efficiency question, it's an energy systems question. So it's really about what energy you're using, where's it come from, is it green? So if we're really going to get to decarbonisation, these two things really come together. So this just gives you a very quick example, but in around 2015, we started to see that there were limitations to the house. It's not a great big chamber. It wasn't purpose built. We were stuck with one Victorian building, which was not an international typology. So a number of partners said, yeah, we like the principle, but actually we don't have any Victorian buildings. So Energy House 2 was really a response to that. So what I'll do now is just pass over to Richard, and Richard can explain some of the thinking behind Energy House 2 and what we're hoping to achieve in the coming year. Thank you.
Hello, my name's Richard. Thanks for Will's introduction there. So this is a quick update and overview of Energy House 2. So Energy House 2 is a £16 million research facility being built at the University of Salford. It's a fairly large building with two chambers with a combined area of about 1,050 square metres. So two large chambers in one building. They can be accessed by construction vehicles, so anything you can move on the motorways or the roads in the UK, including off-site panels and everything similar to that, can be brought into those large doors at the back and built inside the chambers. So obviously this is useful for the off-site construction market. So we're looking at 4 buildings being constructed inside there. So 2 kind of detached starter home style houses in each chamber. So we can experiment on all of those 4 houses simultaneously with different temperatures and climates in each chamber. So they allow for EVs to be connected to the homes, for V2G and V2H solutions in different weather conditions. So as you can see there, flying around the chamber, there's enough room in there to park EVs outside. The state-of-the-art HVAC that we've installed in the building allows us to go down to -20 and up to +40 within 0.5 of a degree of accuracy. So that covers about 95% of the global population's housing, so actually where people live, which is important. So we can take a building from Norway and test it in the climate of Norway, or right down to the climate of the south of France if we so wish. So we can put things like wind, rain, snow and solar radiation on the buildings, and they're all simulated quite well in the chambers there. So this is an idea of what we might do in there. So the basic principle is quite straightforward. We can simulate climates, and we can put them directly onto buildings that we build within the chambers themselves. So which is very novel, and we think is exceptionally useful given the current development that's going on globally in modernising the housing stock. So it's not only about housing. We've also been approached by many people to test things like cars, EVs, anything from tanks for the defence side of things, right through to caravans and all other sorts of things where climatic conditions would be beneficial to test how efficient something is or the thermal comfort in these places are. So that's the model. So we've had a fly around the model. Now we'll have a quick fly around the actual building. So this was taken only about 2 or 3 days ago in August 2021. So the final cladding is on the building. The roof structure is all complete here. We're about 4 to 5 weeks off the actual construction process finishing, and then comes the very sophisticated HVAC that has to go in that chamber as well. So you can see flat roof building with enough space on there for things like PV and things like that should we wish. It's a very modern, striking looking building, I think it's safe to say, but the main thing is it's very efficient in terms of the HVAC that's in there. It's very big and it's very flexible space, and that's really the aim of the game with Energy House 2, is to take all the challenges that we have from developing future housing stock and put them inside this chamber and test them to their limits in essence, but test them to their limits in a very quick way, very efficient way, and a very cost effective way. So these drone images inside give you an idea of the shape and scale and size of the chamber themselves. But like I said, there's enough space in there for 2 starter homes quite easily, with enough height on there to build things as well that are quite tall and allow for crane access. So here's the HVAC just starting to be assembled in the plant room areas up on the 4th floor. So you'll see the air handling units, the pump sets and things like this. This is all fed from a pair of 150 kilowatt chillers down at ground floor level, which provides all the cooled water to these systems. So work in progress, but we're looking at finishing the project December this year, handover in January next year. So it will be finished pretty soon. And there's our details if you wish to get in touch. I look forward to hearing from anyone who's interested in collaborating. Thank you.